Good morning, good afternoon, good evening, or good middle of the night to those of you that are watching this panel at the Layer 1 to 3 World Congress, either live or on demand later. Thank you for joining. My name is Dan Pitt. I'm really pleased to be here. I've been involved with Layer 1, 2, 3 since it was born in late 2011, and I've been to all of the World Congresses except for one. And I'm really happy to be here this week. And I hope you get a lot of value out of this panel on Lean NFV, which is an exciting movement launched a year and a half ago and is now making its way into the market. I'd like our panelists to introduce themselves very briefly. So we start with Daniele.
Thank you, Dan. Thank you for inviting to this panel. Good morning, good afternoon, and good evening, ladies and gentlemen. My name is Daniele Mancuso. I am the Chief Marketing Solution and Business Development Officer of Sparkle. Sparkle is the international branch of Telecom Italia Group. Was spinned off from main company in 2003, basically with the mission to develop the wholesale market abroad and to act as a primary reference for Italian multinational customers. My primary responsibilities are, of course, on the product part and on consulting and partnership and on business development. Thank you.
Very good. Thank you, Daniele. Hey, Eugenia.
Hi, good afternoon and good evening, good morning. My name is Eugenia Corrales. I'm the CEO of Nefeli Networks. Nefeli is a Silicon Valley networking startup, and we're very excited to be here today.
Thank you. Mirko.
Thank you, Dan. Hi, everybody. My name is Mirko Voltolini. I head up the Colt on-demand business function in Colt. So I'm responsible for the development of our network as a service platform and the management of our commercial proposition where we sell, develop and sell on-demand connectivity services.
Wonderful. Thank you. And I've recently sort of retired from MEF, but I'm very active still, and including in the Lean NFV project. And I spent a lot of time advising startup companies and established companies really around the world through the consultancy I've had for about 10 years. Let's look at where NFV came from. And it actually came from right here at the Layer 1, 2, 3 World Congress in October 2012. This was the first Layer 1, 2, 3 World Congress. And at the time it was called the SDN and Open Flow World Congress. And that name stayed for quite a few years and evolved a couple of times. Now it's just the World Congress. But it was launched here by a group of telecom executives that really saw a need with the advent of SDN to virtualize and softwareize their own operations as telecom operators, to really get from a world of purpose-built appliances into a world of software. And the way they did this was to form a group called an ISG in Etsy. And the purpose of this was to figure out what it means to have a software version of what previously had been an appliance. So they defined a number of software pieces that would run not in dedicated appliances, but in commodity servers. And they published the well-known and really legendary Etsy NFV architecture that has really educated all of us on what it means to softwareize the telco. And in this architecture, they defined the main components of the VNFs, of course, the infrastructure, and the management and orchestration MANO and their subcomponents. And they defined the interfaces between them. And there are quite a lot of these interfaces that they defined formally. And people have gone to implementing this in a variety of ways. And we are here today because Lean NFV was created to try to accelerate this implementation and deployment of NFV, which is a really critical concept for deployment of 5G services and services at the edge. So we're really looking forward to seeing NFV get further accelerated with the adoption of Lean NFV. So I want to ask our panelists, really, what was it that caused you to get behind the Lean NFV movement? What has your experience been with NFV? And let me ask Mirko first.
Yeah, I mean, Colt has been very active with NFV since the very early stage. We actually built an implementation of NFV even pre-standard. It was 2011. We built a virtual CP, layer 3 CP, replacing our layer 3 device with an implementation, a proprietary implementation of Provider Edge. Then I was actually in Darmstadt in 2012, where we started the NFV standardization activities. We only actually deployed a standard implementation of NFV in 2016. That was the initial, I think, driven at the time by the very fast advent of SD-WAN in the market. We wanted to be first to market, and we actually went very, very quickly into the market with a dedicated NFV implementation, but it was our first deployment of a white box type of solution, so a step ahead. And then from there, we moved into the ETSI MANO architecture deployment, first with a universal CPE white box on customer prem deployment, enabling us to extend from just purely SD-WAN to multiple type of generic type of VNFs, and then into a second architecture just this year with a telco cloud implementation of NFV. So it's been quite a journey. And in between, we also built our Colt on demand SDN network as a service capability. You need the SDN to enable NFV as well. So that was also a step in the activity. We have started the journey of deploying a commercial off-the-shelf type of service instead of proprietary appliances, and we actually built quite a lot of service capabilities. Our focus has always been primarily on go to market, building service components rather than focusing on reducing costs as opposed to maybe some other carriers. So building components in a virtualized fashion. So it's been quite a journey. We learned quite a lot, but we have had some challenges as well. So it's been quite a learning path. If you move to the next slide, Dan, please. The main challenge we had, and we still have to some extent, is the main one is the operational complexity of the stack we have deployed. If you look at the architecture you were showing, Dan, the ETSI MANO stack defines multiple separate components. It was the intent of disaggregating different components. You have the SDN controller, the OpenStack Vim, NFV orchestration, VNF managers, multiple of them, each one controlling different vendor implementation of VNF. So there is this architecture brings operational complexity. You need to integrate all these different components. That's complexity from the IT development perspective, as well as from the operational standpoint once you have capabilities in production. The other, let's say, main drawback of what we have deployed is the fact that still, even though a standard exists for the overall architecture, there isn't really a standard for onboarding new VNFs and also for the lifecycle management of it. I think a few attempts have been made to drive that activity. However, we don't have a standard today, and that drives complexity in bringing in new capabilities. Another kind of like a general challenge is probably not applicable only to NFV, but to all new technologies deployed, especially complex technologies, a slow ramp up in terms of building internal skill sets. So this brings technology brings the need of combining network, IT, operation skill sets, and we had to transform our workforce. Also, with the challenges of everybody else doing the same, so a tight labor market, not easy to find skill sets in the market. Ultimately, the main drawback and the challenge was the fact that we took we're still taking weeks, many weeks, months to bring new development to the market, and the overall goal of NFV of enabling innovation with a fast deployment and flexibility hasn't really been fulfilled. So those are the main drawbacks. So we're looking to use Lean NFV to improve on all these points.
Very good, thank you. Daniele, what has your experience been at Sparkle?
Well, basically, I can confirm everything that Mirko was saying. Our experience and travel with the NFVI was starting a little bit later than Colt. We started at the end of 2016 with the construction of an internal laboratory where we started to experiment both on SDN and NFV. And actually, our first use case to virtualize was mostly on the wholesale part of our business, because we wanted to tackle the extremely costly part of the voice-based soft switch and the mobile signaling and diameter functions. I think by 2018, we had the initial 4 points of presence that were equipped with NFVI infrastructure. And as of today, we have distributed edge capabilities both in equipped with ETSI and FVI infrastructures, and in some cases also hyperconverged nodes that are providing infrastructure as a service capabilities. We deployed basically this geographically distributed architecture because having customers spread all over the world, we wanted to start with a capillary presence and a very close presence to reduce latency on the voice and mobile applications. If you move to the next slide, Dan, please. Basically, let's fix where we are today. What are the benefits of the NFV as of today? Basically, we moved something from a box to another box. We started in 2012 with dedicated network functions that were running into dedicated and specialized hardware. And what we have achieved as of today is moving them on a commercial off-the-shelf server. But we have introduced a lot of complexity because basically the network function software now is running within a virtual machine. So there are a complex set of interdependencies between the network function code, the operating system of the virtual machine, and the hypervisor responsible for the virtualization layer. There are issues with the performances that are never even close to what they were when the network function was running in hardware. There is an issue of the certification of the server to run properly the virtual network functions. There is an issue of passing directly through the hypervisor capability to accelerate some specific features. The high availability of the VNF cannot run as in other infrastructure as a service configurations into the Vim, but is mostly related to the interaction with the virtual network manager. We have a lot of cumbersome processes, such as software updates that are really difficult because of the interdependencies. And if you click one more, basically what you described before is introducing a complexity in each phase of the life cycle of the BNF, from the testing to the certification, to the onboard, to the life cycle, to the chaining. Basically today, whenever you want to add a new VNF, you enter in a process that is being concluded, if you're lucky, in 3 to 4 months. And again, the complexity is killing the entire benefits of the solution. If you move to next slide, please.
Before we do, I have a question on this slide.
Please.
How much difference would it make, if any difference at all, if instead of implementing these things as VNFs, you implemented them as CNFs, containerized network functions?
Well, the next slide will answer, because this would be already a step of facilitation, in our opinion. So containers, of course, is technology introduced exactly to make applications portable and able to run independently in private clouds, public clouds, independently from the hypervisor. The technology is maybe mature already for applications, but when it comes to network function, there is still development to do. Nevertheless, we consider it the basic step after the virtualization for what we call cloudification of the network function. But it doesn't end up there. Because even if we wrap the network function within a container, we are still dealing with a monolithic function. And in reality, what we see was the original promise of the NFV was the ability to disaggregate, to break up a monolithic network function into a set of components, atomic components, each of them very much specialized for some specific capabilities. And therefore, all the management and orchestration being able to instantiate those cloudified components in different parts of the infrastructure, some of them at customer premises, some of them at the edge POP, some of them in the central data center. So in order to get there, a lot of simplification has to be put in place. And we believe Lean NFV can be the first step of this process of simplification.
Right. Thank you. Now let's ask Eugenia to tell us a little more about exactly what Lean NFV is. I know you work very closely with the inventors of Lean NFV, Scott Schenker and Sylvia Ratnasamy at UC Berkeley. And Scott was an inventor of SDN also and a founder of ONF. So help us understand, okay, now, what do we have with Lean NFV, Eugenia?
Thank you, Dan. So first of all, to your comment, Scott and Sylvia are the founders of Nefeli, and a lot of the ideas that have come forward in Lean NFV is from their research and their work at UC Berkeley. Lean NFV is really a very, very flexible technology that tries to address a lot of the pain points that Daniele and Mirko highlighted. From that standpoint, it is immensely flexible. So there are folks looking at it from 5G applications. It is something certainly that you could use to run your network core. Where we see a lot of traction and a lot of interest right now is for greenfield applications where going all software makes the most sense. And those are things, for example, new SASE applications or people looking at WAN edge as a much broader set of capabilities. In those use cases, Lean NFV really shines for many reasons, which I'll discuss in a second. So those are, I think, where we're seeing a lot of traction for Lean NFV. And the reasons are very clear. Lean NFV minimizes the integration that is required between the different components. And so that enables really fast deployment of new capabilities. It's extremely resource efficient because the integration is minimal, the amount of overhead is minimal. And that allows for applications where resources are constrained, for example, at the edge, at a customer premise equipment. In those use cases, the fact that it is very, very low overhead is a real advantage. It provides for incremental adoption. We've already talked about CNFs. Because again, the integration is so minimal, it's very easy to transition and integrate network functions coming from other sources, whether they be CNFs or something that is open source that you're modifying, or even people that are writing their own network functions to sit on the Lean NFV framework. And all of those characteristics really make it future-proof. So as we talk about having capabilities that are maybe hybrid, where some of it is in your own data center and some of it is hosted in the cloud, this architecture of minimal integration really enables you to transition into future applications and future technologies very easily.
I have a question. Can you quantify resource efficiency and compare how efficient Lean NFV implementations are to maybe more traditional NFV implementations?
Absolutely, Dan. So right now on the demo that we did at MEF 19, the Lean NFV management system was running on one core. So you can run a UCPE maybe at a customer that has only 8 or 16 cores. If you're consuming 8 cores to do your overhead management, you've consumed half of the device. So with Lean NFV, you could run on as little as 1.
And you mentioned that it's really good for greenfield, but you also said it allows for incremental adoption. How do you then add it to an existing NFV deployment?
Oh, that's a great question. I think the most common way I see people doing this is having it side by side. So if I've got an NFV deployment that I'm happy with, that I spent 2 years building, we're not in any way proposing you go rip that out. But as you add new capabilities, you could very easily add a Lean NFV system that hosts new network functions or hosts new services that you're trying to provide to your customers, and therefore, they can talk to each other, and so you can gradually transition rather than having to rip anything out.
Great, thank you.
Okay.
All right, tell us what it is.
All right, so this is a sample architecture from the working group of MEF. Lean NFV really began as an independent effort with a set of signatories that were really supportive of addressing this problem with a much leaner architecture. So it started as a separate effort, and then early this year, it became hosted by MEF because I think the goals of the two teams really align very well. MEF is looking to really provide minimal standards that really enable their members to meet their business objectives, and Lean NFV was really looking for a home where we could really work with a community to drive this architecture. So there is a working team at MEF, and if there's interest from any of you to participate in that, we'd love to have you. Please let us know. The architecture has some key points that I wanted to highlight. At the very top, you see an interface to the MEF Presto APIs. So the Lean NFV system could be something you apply to a specific problem or a specific service that you're providing, and then it would communicate with the rest of your capabilities, the rest of your networking through the Presto MEF APIs. The components of the Lean NFV architecture itself, there are really 4 basic things I wanted to highlight. The first and most important is the presence of a key value store. A key value store is the main mechanism for communicating between the different components. By adding this to the architecture, we enable a disaggregation of the architecture because every component that gets added to the system only needs to know how to communicate with the key value store. It does not need to integrate with all the other components in the system. In many cases, it doesn't even need to know what the other components in the system are. So that's really the foundation of the Lean NFV architecture. There is a virtual switch or a V switch. There are several that are open source in the market that are all very powerful. The V switch allows for all of the data plane visibility. So all of the monitoring and metrics are done through the V switch. And again, that allows for very minimal integration at the key value store level. There is also a disaggregation into microcontrollers of all of the management functionality that is shown here to the right. We've shown some sample microcontrollers and shown how they would fit into the traditional ETSI nomenclature. But again, these are just examples. As an operator, you would build whatever microcontrollers you would like. You could also mix and match. We envision a marketplace where people could offer microcontrollers with specific functions that would easily integrate into the overall system. And finally, last but not least, is the Lean REST server or the LRS. The LRS plays a very important role, but it is a very, very thin layer. All it really does is assure the quality and the security of the key value store. So all inputs in and out of the key value store go through the LRS. The LRS makes sure that the format is correct and that all security policies are adhered to. And so that's a very important component. And as we talk about some of the deliverables from this project, you'll see that the APIs for the LRS are one of the first deliverables that the working team will deliver. So again, 4 components: the key value store, the LRS, which really assures that all information is stored in the right format and with the right level of security, the virtual switch that allows you to manage all of the data that you're collecting to be able to manage the system, and then a set of disaggregated microcontrollers that represent all of the management framework.
Now, if I understand correctly, Eugenia, all those bilateral interfaces led to a lot of complexity, but they also helped us understand what these different subfunctions are supposed to do. And I think that's allowed people to build these microcontrollers and the VNFs and these other components. But it seems like Lean NFV is simplifying their interaction by defining a uniform interface to the LRS, which houses the key value store. Do I understand this correctly?
Yes, correct. So you can build any management system, right? It has to talk to all of its components that it's impacting or managing. And you could do that with a set of pairwise APIs. And that's been done and it works. And a lot of people have systems that are running that way. And we are in no way suggesting that they change that. I think the advantage here is by getting that integration down to its minimal level, which is a set of APIs to the key value store through the LRS, you're able to minimize that integration, which minimizes the overhead and which allows the system for a broader set of innovation from a broader set of sources because it is a disaggregated architecture.
And what kind of information is actually stored in the key value store?
The key value store initially will store from a network function perspective 2 pieces of information. It will store the both state information. So it would store I'm up and I'm ready to take traffic. That's it. All the other information around how much latency it's seeing, how much traffic it's seeing, all of that information is measured directly through the virtual switch. So we don't need to do that integration there. So that's the integration with the network function. With the management controllers, one of the things we're doing as a working group is deciding which initial functionality do we want in the management controllers, because you could have a broad range of functionality that you could grow over time. So the goal would be to create enough functionality in the management microcontrollers to obviously allow you to configure and boot the system, as well as to receive information through Presto on a service chain and to launch and manage a service chain. So those are the kind of the 4 pieces of basic functionality. So from the standpoint of the management framework, the key value store would store information like where are the licenses located, what is the configuration file for that particular network function, et cetera.
And it looks as though these components are fairly independent of each other. So could you imagine that these sample microcontrollers could each be written by some third party that's really good at analytics or failover or things like that, and others with the VNFs, of course, and even the EMSs? How likely is that sort of phenomenon in the software industry to emerge from this?
Well, this isn't unheard of, right? So projects like Kubernetes, for example, have really successfully allowed contributions from different sources. So there is precedent to do that. We need to do a good job of defining these APIs so that that's possible. But I absolutely envision, a scenario where, maybe I am an expert in analytics and I have some really specific network-based analytics that I want to put in as a microcontroller, and an operator could take that and use it and not have to modify the rest of their system, right? Okay. Or I could write a network function with a very specific functionality that I need for my use case as an operator, and I could put it into the system and not have to worry about retesting everything and reintegrating everything, right? So
okay. Thank you.
Okay, so I get this question all the time. What's Lean about Lean NFV? So I wanted to just really highlight this as you think about Lean NFV. There's really 3 reasons why it has this name. The first we've talked about, it is a minimal integration. So we got down to the absolute minimum possible integration between the different components of the system. And so that's a very important piece. The second is that minimal or no operational metrics are actually obtained from from the network's functions. That is a big part of the integration challenge when you build an NFV management system, is you have to know which network functions you're working with. You have to understand all of their APIs, and you have to gather all the information through those APIs that you need to be able to manage that network functions. With Lean NFV, we're measuring all of that directly through the vSwitch. So the only pieces of information you really need to know about the network function are stored in the key value store, and you know where they're stored. You know for every network function exactly where they're going to be stored. So that's the second reason for the Lean name. And finally, the net result of this is very low management overhead. You've already asked me, Dan, you can get down to, it's been demonstrated that you can get down to as little as 1 core. Which is very powerful when you're building edge devices that have very limited resources.
Good, thank you.
Okay, and then just a little bit about the objectives of the MEF effort. The MEF effort was launched in the February-March timeframe. It became an official standards project in the month of July. And we have a very active working team working on the following 4 initial deliverables. The first, very obviously, are the API specifications into the LRS, which is how you would communicate with the key value store. The second, and we very purposely separated it, is what that initial key space will be. So what values are going to be stored where initially in the key value store. And we separated the two because we wanted to be able to modify one without impacting the other. The third is obviously the northbound connection into any other kind of management system, or OSS, BSS system, or any other customer portal that an operator might have. So all of those would communicate with the Lean NFV system through the Presto APIs. So we need to define those as well. And then finally, I mentioned this already, we wanted to define what is that minimal set of management functionality that we need in this first phase, so that we can focus on that and enabling that, and with the goal, obviously, over time of expanding those management capabilities. And as you said, Dan, maybe creating a real a place for innovation where people from many different communities can contribute to the management framework with specific microcontrollers.
That's great. And I'm on the calls every week, and Sparkle and Colt and other operators and other vendors are actively contributing every week. And it's a really exciting project. And if your company is a member of MEF, you can just join the project. There's no overhead, there's no charge. If you're not yet, it's worth joining for that reason. So tell me a little bit, Eugenia, of what Nefeli as a company is doing, not in the context of the MEF project.
Great. So Nefeli, as I mentioned earlier, is a company in the networking space that is based on a lot of the research that our founders did over the years at UC Berkeley. We have built a product which is called Nefeli Tapestry, and it takes a Lean NFV architecture and applies it to the network edge problem. So we've focused on that specific problem, and we have a working system. We've been in production since April of this year. And the product, I've got a little screenshot there of what the dashboard looks like, which is always fun to see what the product actually looks like. There's a few things I wanted to highlight about the Nefeli product. The first is that Nefeli enables our customers to run whatever network functions they want. So if they have a specific SD-WAN vendor that they like, or a specific firewall that they're familiar with, or they want to write their own network function, or they want to modify an open source network function, all of those can be hosted on our system with very minimal integration. And we do that for you. So, within really a few days, you can have a network function up and running in the system that you're using. We have invested a lot in automation and really enabling things like scale up, scale out. We have very policy-driven commands so that you don't have to know what cores are sitting where and what server and where each network function is housed. We take care of that for you. And this is really important as you think about providing things like security and visibility across multiple edge deployments. We can run on any environment. We're running in the cloud, we're running in data centers, we're running in small UCPEs and branch offices. And then finally, because we are Lean NFV based, it is an open architecture. It is very easy to deploy and operate, and it's open. So the goal would be, that we work with the broader Lean NFV community and participate in that by bringing capabilities, but that others will do so as well.
That's great. Thank you, Eugenia. Daniele, what is Sparkle, corporate doing? I know you're active in the project. What is the company doing about Lean NFV?
Well done, as you said, apart, let's say, actively participating to the MEF project, for the standardization and for the put in production as soon as possible. We are pragmatically working on a MEF 3.0 proof of concept that should showcase in January 2021. Here you can see basically the composition and the diagram of the POC. Participants, of course, Sparkle as a connectivity and the private cloud provider, Nefeli with the software stack that Eugenia was just defining, and Amartus as end-to-end system integration. There will be also a VNF vendor, a SASE VNF vendor that we have not yet identified. I mean, we are working with a set of potential participants. We are analyzing what can be the best fit at the moment. The idea behind the proof of concept is very easy, is to establish an end-to-end connectivity between a remote user location, home working, since we are in a COVID flavor, let's say, and a public cloud provider, can be AWS, Azure, or even a combination or in a multi-cloud environment. And the purpose is to have a unified networking and security policy that is applied across every single part of the connection, from the remote home up to the public cloud, traversing the entire Sparkle network if it's needed. So I think it's a very, very interesting scenario. It's a very interesting operating environment. First of all, because we are, going to apply really to make real the SASE story. So we are going out of the buzzword of the market part, and we are going really on a serious implementation. And second, because this will be done on a Lean NFV environment. So our purpose is to demonstrate that everything that Eugenia was saying before is reality, and that service provider can just benefit about it. If the POC will be successful, as we all believe it will be, together with the development that the MEF project will have, we can plan a production phase in dedicated environments. Of course, we are mostly looking at customer premises. We are mostly looking at edge installation, but we are also looking at interoperability with what we have implemented so far, because definitely we are not going to throw out all the money that we have spent in the implementation that we have as of today.
Very good.
That's in a nutshell.
Thank you. Well, I certainly look forward to seeing that POC when it comes out and to hearing more about your go-to-market plans. Mirko, tell us what, there we are. What Colt is doing with Lean NFV.
So as often, we have a very ambitious plan. We run already a POC in our lab in a controlled environment, which has been successful. Decided to go ahead and select Lean NFV as a technology to enable our expansion of our on-demand platform in the NFV, more in the NFV space. Currently, we're running a production pilot, so it's beyond the initial POC. Is actually now in a production environment, and not yet operational, but in a production environment, using Nefeli technology for a specific use case, which is internet access on demand, which is part of our current service proposition. The intent is to go live in production during 2021. I'm not setting a specific date. This is still early stage from the technology standpoint, but we aim to go to market as quickly as possible. And from there, the intent is to extend to other VNFs we have currently in production. Lined up is our multi-cloud on-demand capability, moving the current dedicated SD-WAN gateways we have into this environment and our SASE platform as well. That's more in the near future, so after the initial deployment. Potentially more in the long term is extending this capability into the not just in the initial deployment is a telco cloud and AVI central edge and core use case, but moving that into the universal CPE, so on the customer premise deployment space is going to be part of the next steps in the future. So lots of expectations for a challenging plan, but also lots of expectations from the technology. We expect to see, as we've seen in the initial POC in the lab, a radical simplification of the architecture we have seen so far, as I described earlier, removing some of the complexity, so much simpler stack for us to use for development and for operation. Simplified operation, so removing this separation of components as the end controller, no more separated Vim, no more OpenStack. Eugenia was talking about the size and the amount of resources that the current stack consumes. So OpenStack is a good part of that, and removing it will help us reduce the load, especially on a smaller device implementation. And ultimately is going back to my main objectives is going to market faster with new capabilities. So faster VNF onboarding will lead to a reduction of the development life cycle and eventually bring us to deliver that innovation we have been aiming for with NFV.
Well, I like the idea of radical simplification. That would certainly help the industry to move forward more quickly, and as they say, move at the speed of software. Thank you for your remarks. We have some questions that we have drafted for polls. Now, we are recording this in advance, so we're going to be answering the questions. Q&A will be live when we finish this. We'll leave some time for that. But I wanted to talk about the poll questions that we conceived. And in the absence of being able to respond to the audience answers to these, I'd like to ask our panelists, and I'd like to focus here on the operators, what your experience and plans are for essentially for VNFs, which is, you know, the deployment in the marketplace of open VNFs is, I think, a desirable goal for all of us. So let me start with you, Mirko, in question one. And we'll keep this fairly brief. Where do you anticipate employing VNFs?
So the current implementation we have is in the central data centers and on customer premises, B and D in this question. The intent is to move actually with the Lean NFV into the provider space, so a more distributed deployment. Actually, I didn't say earlier, we're going to deploy side by side with the current Etsy Mano stack, so that will be a central data center and Lean NFV at the provider edge. And the intent in the future is also to go into the public cloud. So at some point, we'll tick all the boxes.
Thank you. Daniele.
Well, as I said before, we started more from wholesale flavor of virtual network functions. So we deployed initially in our central data center, and we activated the few provider edge locations for customer proximity. In the move that we are doing now in the space of SD-WAN and more on SASE, and considering the capabilities of Lean NFV, we anticipate a strong move towards customer premises and even more proximities at provider edge. But we do not exclude at all the public cloud implementation, because especially on markets where we don't have a significant network premise, we could decide at least initially to go in public cloud and then eventually to instantiate on our premises when our POP are up and running.
Thank you. Daniele, why don't you continue with question 2 of where you get your VNFs or CNFs?
Well, at the moment, basically, I would say 90% of them are coming from our main system vendors. I would say even traditional system vendors from where Sparkle was already procuring traditional physical functions are moving into the space of VNF, and we are acquiring from them. Very small part is coming from system integrators, but I would say it's really a minimal part. At the moment, we do not write, and we are not anticipating to write by ourselves, and we are not yet confident about independent VNF authors. So we'll see how things will evolve in future, but I would say that B and C is the Sparkle target at the moment.
Okay, thank you. Mirko, where do you get your VNFs?
So at the moment, it's 100% from our main system vendors. The intent is to go, actually, probably should be an E to this question. We also aim to deploy open source VNFs. Maybe that's part of the. We don't also plan to write VNFs ourselves, at least not for the moment.
Okay, thank you. And finally, Mirko, how long has it taken you and you wanted to take to onboard and expect to take to onboard VNFs before and after Lean NFV?
So the experience in the beginning, we actually were taking more than 3 months. The first few implementations, probably that's expected. It was a learning curve. We're still, and as I said earlier, it takes a few months. So 2 to 3 months is the current typical performance. We're aiming to get to lower than 1 month for sure.
And Daniele, what about you?
Well, same here. I would say that at the beginning, when we start our travel to virtualization, we were far beyond the 3 months. Today, the standard is 2 to 3 months, but we are really confident that with Lean NFV, we can go less than 1 month.
Thank you. And I'm going to throw this at you, Eugenia. What's your target for Nefeli networks in terms of onboarding time for VNFs? Not really what you're delivering right now, but what do you think is achievable?
So what's achievable, I think, is days. If we have a VNF that is Lean NFV compatible, which is what the MEF standard strives for, then it should be, seamlessly integrated. Of course, you'll want to test it, but you should be able to onboard it, within a couple of days. And so that's really the goal. Today, we're doing so in less than 1 month, but there is some integration work that's being done today, since they're not inherently Lean NFV network functions. So.
Mm-hmm. Well, I think we all look forward to the day when it's like deploying any other piece of software. Yes, you have to test it. You can load it, it integrates fine. You don't worry about those things. Is it doing the functions it was intended to do? And can you manage it? And I hope we get to that really in pretty short order. I'd like to thank our panelists for the remarks. We're going to go live for Q&A after this is over. But thank you, Daniele, Eugenia, and Mirko. I'd also like to thank MEF for housing this project, for the leannfv.org for starting it, and Etsy for really infusing the whole idea into the telecom industry of softwareization of telecom operations. Thank you all for attending this, this panel discussion at the Layer 123 World Congress, and I look forward to your Q&A after the recorded panel discussion is over. And I hope you enjoy the rest of the conference throughout the week.